Okay, video number 9 is about lenses. More common questions in terms of drawing these diagrams come on higher tier papers, but you must make sure that you understand the difference between convex or converging lenses and concave or diverging lenses. In this diagram, figure 3, a convex lens is bringing parallel rays of light to a point. It's a converging lens, and the point where the lines meet is known as the principal focus, and the distance that point is away from the lens is the measure called the focal length of the lens. In the second diagram, we're looking at a diverging lens that causes parallel rays of light to spread out. There is no chance of the light meeting to the right of the lens, and so these dotted lines are showing where these would come to a point, and again we refer to the principal focus of the lens. Lenses can be used to make images, and the images can be bigger, smaller, or the same size as the object, and the size of the image depends on how far the object is from the lens, as well as how powerful the lens is, in other words, what its focal length is. When you're drawing these diagrams, and I suggest that you practice them, make sure that you work with a sharp pencil and a ruler. The lines that you need to draw for a convex lens are always parallel with the principal axis to the lens and then down through the focal point. The second line should be diagonally through the center of the lens, and if you wish to draw a third line, it's diagonally through the focal point and parallel with the principal axis on this side. You can get away with only drawing lines 1 and 2 to show where the image forms, which is where these lines cross. Practice drawing these diagrams with the object beyond 2F, between 2F and F, and between F and the lens. A special case of when the object is very close to the lens is shown in figure 3, and somebody looking through the lens will see a magnified image of the thing that you are looking at. This is how a magnifying glass works. Notice that the lines, 1 parallel to the axis and through F, and 2 diagonally through the lens, are never going to meet, and so they have to be virtually taken backwards until they meet, and that's where the virtual image forms. A good definition of a virtual image is one which does not have light passing through it. So a convex lens can form diminished, magnified, virtual and real images depending on where the object is. Our concave lens, which is shown here in figure 4, will always make an image that is virtual. And I can see that it's virtual because this dotted line shows where I have to imagine the light is going in order to form an image, and the image will always be upright and diminished as well as virtual. So make sure you are completely happy with drawing these diagrams, and if they're to scale, you can calculate the magnification using this equation here. Remember your words for describing images, and there are always 3. Are they real or virtual, upright or inverted, magnified or diminished? And the website, which you can see on this slide here, is an excellent way of moving an object and seeing immediately how that changes the relative size of the image.